Since 1887, Yamaha has been at the forefront of musical instrument innovation and technology. Yamaha's intimate knowledge of musical instruments and producing sound made providing reproduction systems equally important. In the early 1970s, Yamaha engineers started planning and designing some of the most accurate sound equipment available. This tradition continues today. Loudspeakers are one of the hardest to design links in the audio chain. They have the job of changing electrical signals into acoustic energy. Yamaha's Club Series loudspeakers were created to give professional quality results at prices gigging musicians can afford. For nearly 20 years, we've continued to improve the performance of this popular line of loudspeakers. After numerous discussions and visits to customers all over the globe, Yamaha engineers developed Club Series loudspeaker systems that offer the best possible performance and durability at affordable prices. Sonic performance is first and foremost, and since these engineers are also gigging musicians, ergonomics and professional appearance are also taken into consideration. To ensure quality, Yamaha proudly uses custom-made drivers from Eminence, the largest professional driver manufacturer in the U.S. Each low-frequency and high-frequency driver is custom-made to our rigorous specifications to meet the exacting tolerances Yamaha standards require. To see what goes into a Club Series loudspeaker, it's important to understand the various parts that make up the system. Let's have a look at the major components. Most people will recognize the woofer, or low-frequency driver. Whenever you listen to music, that low bass sound is produced by the low-frequency driver. It converts most of the electrical current coming from the power amplifier into low-frequency sound waves. Since lower frequency sounds require more energy to make the same sound pressure level, or SPL, than high-frequency sounds, Yamaha engineers developed drivers that can do this without adding distortion, while at the same time protect the driver from its worst enemy, heat. Yamaha designed the low-frequency drivers with features that improve both performance and reliability. At Eminence, a low-frequency driver begins when a 30-ton press punches 3/8-inch thick cold rolled steel for the magnetic assembly. A cast aluminum frame is commonplace for professional woofers. This feature actually serves several purposes. Heat dissipation. High-power, low-frequency drivers not only generate a lot of sound, but considerable heat in the process. Aluminum is an excellent conductor of heat and can carry it away from the voice coil, allowing even higher power capacity. Cast aluminum is very stiff and doesn't flex or bend as easily as a steel basket. This allows the driver to work more efficiently and produces less distortion when compared to less costly steel construction. Using strontium ferrite magnet assemblies weighing as much as 16 pounds, extremely high flux density can be developed. This magnetic field is what the voice coil will work against, producing movement to generate the sound waves. The heart of any low-frequency driver is the coil of wire that resides in the magnetic gap at the center of the driver. The diameter of this voice coil needs to be large enough to allow high power handling while maintaining good efficiency. Professional drivers also employ a technique of flattening the wire before it is wound into the coil. This flat winding allows more of the winding to stay in the gap of the magnet for better efficiency. For precision and low loss, Yamaha specifies that only oxygen-free copper wire be used for all the Club Series drivers. Now, flexible leads can be attached to the finished voice coil. Then, it's electrically tested. And the voice coil gets placed in the basket. A spider is attached next to ensure alignment of the voice coil in the magnet's gap. For lower distortion at high output levels, adding an arc into the structure of the cone makes it much stiffer without adding extra weight that would affect efficiency. With this design, the woofer's cone can act much more like a piston to form the air into sound waves. Stiffening the cone is also very helpful to reduce distortion. Effectively removing heat from the voice coil is mandatory for high-power operation. Yamaha's Club Series woofers use a vented pole piece to allow cool air to circulate in the magnet's gap where the voice coil operates. This method of cooling, common in professional designs, allows very high power ratings while still maintaining low distortion and high efficiency. Adding the edge treatment to the cone ensures long life, flexibility, and protection from the elements. A cover is applied to protect the magnetic gap from dust and to channel cooling air across the voice coil. Once completed, the loudspeaker is completely assembled. It's permanently magnetized. The voice coil leads are attached. And after a final quality check, they're ready to be shipped out to Yamaha. Another easily recognized part of a loudspeaker is the high-frequency driver. Hidden behind a horn in Yamaha Club Series loudspeakers, the high-frequency driver, sometimes referred to as a tweeter, has the job of converting the high-frequency electrical signals from the power amplifier into acoustic energy, or sound waves. The human ear can detect distortion at high frequencies much easier than at low frequencies, like those generated by the woofer, so designers pay a lot of attention to this driver. Tight tolerances and quality control are key in assuring optimum performance from a high-frequency driver. Let's have a look inside and see how Yamaha addresses these issues. The heart of any high-frequency driver is its diaphragm. This single part is responsible for vibrating and producing all the acoustic energy the driver produces. The high-frequency sound waves require a fast-acting diaphragm with sufficient size to accurately reproduce the sound with output levels high enough to keep up with the low-frequency driver. Engineers select the lightest, stiffest materials available to ensure the ability to reproduce very high frequencies with minimal distortion. For the Club Series, Yamaha asked Eminence to use pure titanium, as it is one of the lightest, most rigid materials available for this task. This pricey material is carefully formed into an extremely rigid dome 2 inches in diameter. Large titanium diaphragms of this type are usually reserved for much more expensive loudspeakers. But since the engineers wanted high output, or SPL, without distortion, the extra cost was justified. Another benefit of a large diaphragm is its cooler operating temperature, again reducing distortion. Due to its lightweight requirement, the voice coil wiring is considerably smaller than the wire used in a low-frequency driver. Tolerances in a high-frequency driver design are within hundredths of a millimeter in order to maintain consistency and avoid distortion. Even slight variations will cause technicians to reject its use. After the voice coil has been wound and tested, it is prepared for attachment to the titanium diaphragm. This process requires baking